Hello people, welcome back. This question is from GATE 2019 exam and it is for 2 marks. Question is, if we call this function convert and pass some positive integer as a parameter, what will be printed? So let's see what is printed. Suppose we are calling this function convert and the integer that we are passing is 5. So we are calling this function convert with 5 as parameter. Now whenever you call some function, a activation record will be pushed on the stack. All the local variables will be allocated in this activation record. So int n will be declared here. Okay. And we are passing the value 5. So value of n is 5. Now let's start executing this program line by line. If n is less than 0. No, n is not less than 0. So we need not execute this line. Simply execute the lines present inside the else block. So it is again a function call and this time we are calling function convert with parameter as n by 2. So a new activation record will be pushed because once more we are making a function call. That is this function convert. So int n will be declared once again for the new call here. Okay. And the value that we have passed is n divided by 2. So n is 5. 5 divided by 2 means 2.5, but int n means n is an integer. So 2.5 cannot be stored in n. N can store only its integer part. So 0.5 will be neglected and only 2 will be passed. Okay. Now see, whenever this function call is complete, that means after executing all the lines of this function, you have to come back to this function and execute this one remaining line. Okay, so let us say it is line number L. So I have labeled it as L and let us remember that line L is remaining. Okay, now this new function, it will start its execution from here. If n is less than 0, no, it is not less than 0. N is 2 for this function call. Okay, that means we have to execute this only. So convert n by 2. This means a new function is called and the value that we are passing is 2 by 2, which is 1. Okay. Now, when this function has completely been executed, that means when all of the lines of this function are executed, then you will return back here and you have to execute this one line. So I'm labeling this that line number L is still remaining for this function. Okay. Now let's talk about this new call. Is n less than 0? No, it is not less than 0. That means you will again make this function call. So new function is called and the value that we are passing is 1 divided by 2, that is 0.5. But we will take only integer part. So value that is passed as 0. Okay. Now after coming back, we have to execute line number L. So I'm writing L. Let us see what will happen here. If n less than 0, is n less than 0? No. So this print will not get executed. Else will get executed. So convert function is called and the value that is passed is 0 divided by 2, which is 0 only. Okay. Like this. Now for this new function call, again same things are going to happen. You are going to call convert 0. So new function is called n is equal to 0. Again a new function will be called n is equal to 0. Again a new function will be called n is equal to 0. So this will keep on happening infinitely. Okay. See, you try to execute this program line by line. So you executed it till here. When you reach this point, this line says again call the same function only. So you again started from here. When you reach till here, this line says again do the same thing. Okay. So it keeps on happening infinitely. Nowhere value of n will become less than 0. You can see 5, 2, 1, 0, 0, 0, 0. Value of n will never become negative. Okay. So this will keep on happening infinitely. So what is the answer? What is this program printing? We haven't even executed print statement once. So this program, it will not print anything and it will not terminate. Answer is, so let me just display the options. So you can just read the question also. Have a look. Option A says it will print binary representation of n. No, it will print nothing. Option B also says it will print something. Option C also says it will print something. Option D says it will not print anything and will not terminate. So option D is correct. Okay, it will not print anything and will never terminate. Now see, theoretically speaking, it will not terminate and answer will be option D. But practically, what will happen? The stack will just keep on accumulating more and more activation records, and eventually there will be stack overflow. Okay, you will run out of memory. See, we are declaring these variables again and again, so you will run out of memory and the OS will forcefully terminate this program, okay, or this process. So practically what will happen? Nothing will be printed, but this program will be ended. That too, it will be a forceful termination that is done by the operating system. Okay, so now let's do one thing. I'll just show you the laptop screen and we'll execute this program also. But before that, let us analyze option A. Option A says it will print the binary representation of n. See, this program might print binary representation if you make a few changes. That means whenever n becomes 0, so n equal to 0, in that case, you simply return. Okay, replace this line by return. When n becomes 0, you have to return, else call this function for n by 2. Let us just try running this, what will happen. So now forget about all of these records. Suppose that stack is empty. Okay, so we are calling this function for n is equal to 6. Okay, say. So first time n will be 6. I am writing 6 here. Then 6 is not 0. So simply call a new function for n is equal to 3. Okay, n is equal to 3 will be called. And remember that this line number L is remaining for this function call. Okay, so I am writing L here. After this, for the new function call, that means this one, let's execute the line number 1. If 3 equal to 0, it is false. So execute the else block. Okay, convert n divided by 2. N divided by 2 will be 1.5. That means 1. Okay, just ignore the decimal part. Then you have to execute this one line after the new function returns. Okay, when this function returns, you will come back here and this remaining line will be executed. So I'm writing L here like this. And then you'll just execute the line number 1 for this function, the one that is called right now here. Okay, so first line is 1 equal to 0, which is false. So again you'll make a function call. This time the value that is passed will be 0. Okay, so because 1 by 2 is 0.5, so 0 is passed. Now see, you have passed 0 here. And this time, if 0 is equal to 0 is true, so you will execute a return statement. Okay, this function, it will simply return without printing anything, and you will come here. Now what will happen? This line will be executed. See, line number L is remaining for this function, so execute line number L. Printf n modulus 2. So 1 modulus 2 means divide n by 2 and print whatever is the remainder. Remainder is 1. Okay. Then you have executed the last line of the program, last line of the function for this function call. Because last line is executed, so this will also return. Okay. Then here also line number L is remaining. So 3 modulus 2 will be printed. N is 3 and modulus 2 is 3 divided by 2. Just take the remainder, which is 1. Okay. Now this one will also be popped because for this function call, all the lines have been executed, including this last line. So you will return to this function call. Here, what you are going to do is n modulus 2 will be printed because only line number L is remaining. Okay. So 6 modulus 2, n is 6, 6 modulus 2 is 0 because 6 is completely divisible by 2. So 110, which is binary representation of 6 is printed. Okay. So for each and every number, you can just print its binary representation just by passing this number as parameter. Okay. If you pass say 14, if n is 14, then this program is going to print 1110. Okay. If n is 28, then this program will print 11100. Okay. So now I'll just show you the laptop screen. Okay. Okay, so you guys can see I've just written that program. So this is the function that was given in the question. To this I've just added the main function and this header file. Okay. Now let's start executing it and let's see what happens. So as you can see, nothing happens. After some time, this program ends with return value that is not 0. Okay. See, main function returns an integer to the operating system. Even if I write return 0 here, this will never return anything because this line will never end. It will keep on recursively calling this function convert again and again, and return 0 will never get executed. So even if I write return 0, this main function will never return 0 and this program will never successfully terminate. Okay. So if program or main function returns anything other than 0, this means that the program has been terminated forcefully by the operating system. And 322.122 something, this may be for stack overflow. Okay, this code may be for stack overflow. Now you have a look at this program. I've just replaced this n less than 0 with n equal to 0. See here in original question that was given in GATE exam, we had these lines: n is less than 0, then printf n. I've just replaced this and this return statement is written. Okay. So we are passing 18. 18 in binary is 100 and maybe 10. Okay, so this must be printed. Let's see if this gets printed. So 10010, yeah. And see, return value is 0. Okay. So even if you don't write return 0, still it is done automatically. Anyways, let's write some other value here. Let's pass 20. Let's see what is the binary representation of 20. So you can see 10100. This is 20. Yeah. Now have a look at this program also. This is almost similar to the original program or original convert function that was given in the GATE exam, except for this change. I've added a static integer named x, which is initialized to 0. Okay. And every time this function is called, we are incrementing this value of x. Okay. So this will tell us how many times this function has been called. So in this print statement, before calling the new function, we are trying to see what is this n by 2. So here I am printing n by 2 is %d. So this %d will be replaced by this n by 2. And the other thing that we are printing is function has been called for %d times. This %d will be replaced by x. Okay. So every time you call function, x will be incremented. So you can easily see, we'll get to know how many times the function has been called. So let us just execute it. See, n by 2 is 0. Every time it is 0. So whenever this new activation record is pushed, n is 0. And the function has now been called for almost 10,000 times, 8,000, 15, 17, 25,000 times. And it will keep on happening until the OS decides to terminate this program. I think it's terminated, yeah. So the function has been called 43,178 times. That's a very large number. And the return value is same that we got in the previous program. So this might be the code for stack overflow, and the program has been forcefully terminated by the operating system after this much time. So now let us just run it for one last time and see what is the value of n for first time. First time you are passing 5. Okay. So what will be printed here will be n by 2. So n by 2 must be 2. Let us see. So have a look. This is. So you can see on the top it is written n by 2 is 2. Okay. Just a second. Yeah, here. So n by 2 is 2. Then n by 2 is 1. Then n by 2 is 0. Then it keeps on remaining 0 for every function call. Okay. So I'm ending this program here. Thank you very much for watching this video. Have a good day.